Thanks everybody for being here. My name is Brian. I'm from Argentina, and I'm friend with Andres. So he arranged this. So thank you. That's it.
For joining.
I work at Manas, and for the last couple of years, we've been developing Crystal. I don't know if, besides the flyers that were hangouts in the walls, if you know the language or if you have read something at all. No, right.
Awesome. The name mentioned a couple times.
Right.
Yeah, I've seen the name, maybe like on Hacker News or something.
Yeah, we are not that famous, but we are getting there, probably. So, as background, this is the language made almost from scratch by ourselves. There are some building blocks like LLVM where we are heavily based. So it's not that we do all the chain of the compiler, all the tool chain of the compiler, but over at LLVM, everything is built by ourselves and by the community that is being starting to grow there. Sorry for my English. I'm not a native English speaker, so I can.
Your English is better than my Spanish.
So at Manas, we usually used to write code in Java or in .NET. Many years ago, we shifted to Ruby. It was really an exciting moment. It was fun for us. It is a language that we love a lot because it was a fresh air. We started coding really fast. It was a great community, much more open than in the other languages. So it's a really great experience for us. But as times goes by, we were happy, but the computer weren't that happy as us. Because Ruby is aimed for joy of the developer, not so much joy of the computer, although it's getting faster and faster. By the underlying mechanism of how Ruby works, it's a dynamic language. It's really dynamic, and there are a lot of things to be done during runtime, penalizing the performance of your product. So we like the syntax, not that much the under the hood things for the computer. Although, for example, the community is really great, so we want that on this language. And usually compiled language are more efficient because they generate native code. There's not so much things to do on runtime. It's well known that compiled language are usually more efficient than interpreted languages. And yeah.
It's interesting here, where I work, we use Git for the front end, and now all the talk about what to use as the next generation UI talk. I work as a SWE in the display ads team for DoubleClick, and it was all about, they don't want to use JavaScript, they want to use something more robust, and work between TypeScript and Dart. And it's all the motivation that happened here with building Dart instead of using JavaScript. They're having a similar issue with why building Crystal instead of using Ruby.
Yeah. In some aspect, we're going back in history a couple of years ago and say we want some safety nets when we are programming. We love to have joy, but give me something. I try to catch a lot of errors, for example, by using type checking. Nobody wants to do type annotations, but if you have type checking, you will love it because it's a secure thing to have, that the compiler will tell you, no, you're making things wrong, you are doing things wrong here. So these are kind of the aspect that we love the syntax. We want to be more performance, even to consume less resources. So we have a greener language. It's expending less energy in runtime, and try to catch errors as soon as possible. So we want to merge that in this kind of language. So as I said, we like Ruby. Maybe I don't know if you are used to Ruby. Maybe you're more in Python, but if you know Ruby,
Probably guess. I mean, I know Python, but they're similar, right?
yeah, similar. It's just like you need to agree on which is the keyword to define the methods and the classes, and more or less, and if it is indentation or and the same are indented as in Python, or you have an explicit end as in Ruby. But so you can define classes and methods and basic object-oriented stuff. And for example, this snippet, it's almost a Ruby code. It isn't entirely Ruby because of one type annotation. The name parameter should be a string. But it feels like Ruby. It's you're not declaring variables. You're just using it. You have some idiom for instance variables with the @ sign. And you have the constructor name initialize. It feels like Ruby. You have a string interpolation. You have a nice set of features. And although here we see a type annotation, actually it's only one, and there could be like 4. You have the instance variable, the G variable, the return types. There are other types going around, and we only annotated one for making it to compile. I will show later why on this case we need to annotate the types. But this is how does it look like. And for a static type check, it means that running the compiler without actually executing the code, if we make silly mistakes like adding a string and integer, we catch some, we have some nice compiler errors in form like no overload allowed for that in that particular line. And that is before executing the code because we don't depend on the actual values. It's a compiled language. If I'm too basic or something is not clear, just push it forward because
Yeah, and you have type self there on the previous page. Does that mean it's usually a bounded polymorphism or something?
Yeah, it means that the other parameters need to be the same type as the containing class.
Okay.
So it's.
And how do you type that?
It's because it's declared in the class in the string class.
Okay.
It's just a way to refer to the current type.
So it's a shorthand for string, or it actually means the same?
No,
type
it's because the syntax declaration. Maybe we should avoid naming self in that error and just replace that string. But in the standard library, when you open the class string, if you refer to self and not in the lexical scope, it's the class.
Okay.
But if then you are in a method, it's the object itself.
Okay, right.
So it's just a shortcut for the lexical definition of the class. We should avoid that. And by native code generation, we output assembly code. Like by using LLVM, there is no virtual machine under the hood. You just go bare metal to the targeting to the specific processor and consuming less memory. So there are a lot of tools to deal with those binaries, ugly tools. But maybe you're interested in that story or not. I usually a bit more abstracted than the architecture in my personal day-to-day. But you can see the assembly, and it's similar to what a C code compiled with LLVM it's end up doing. It's pretty similar. You will see the calls and all those weird things going there in the assembly code. You can even inline assembly on Crystal. It's crazy stuff. But so we wanted that, and the community started to get bigger. There are some community members that like benchmarks a lot, so they start coding the same benchmark in different languages. This is Kostya is one of the contributors that is outside Manas. So there are three benchmarks I want to show you. One is a brainfuck, and it's like building an interpreter of the language, of brainfuck language. C, Crystal, and Go has similar performance, although a lot different syntax between each other. And Ruby, which is similar to Crystal in the joy of the programmer, has way other performance here. Another is, for example, a benchmark that does matrix multiplications. Here again, C, Go, and Crystal are pretty similar between each other, and Ruby is outperformed by the others. Although the memory here is pretty similar between the 4 languages. And then there is another example which does a lot of numerical computations. I'm not sure what are the details, but it's the benchmark he did. And here Crystal outperforms slightly C, a lot of Go, like half in the time. Python, and we are not able to show Ruby because it's probably still running. But now we'll add Ruby, but this I don't know. It wasn't included there in the chart. I don't remember what's the actual reason. But and in memory, well, C is able to perform better in this case. But you see the performance that we already have is pretty nice. So that's what we currently have, been developing for the last more or less 5 years. We reached the 7,000 likes on GitHub. Like there, we want more. And on the repository where it is the compiler and the standard library, you can see that the main language used is Crystal. So the compiler is written in Crystal itself, which is pretty nice for a language to be written in itself. That means it's already bootstrapped. So actually, if you want to learn Crystal, you can start reading about the compiler and contributing there, or just modifying the standard library. And you never need to go to other language to make performance, like a performance implementation of an array or of a hash. It's all aimed to be implemented in Crystal itself, and then LLVM handles a lot of optimization for sure. But that's the idea. And don't need to leave the language to make some performance. For example, in Ruby, the internals are implemented in C for performance. So if you need to, like the equality comparison between strings, you jump to another language to implement Ruby. It's understandable that it's necessary, but it's kind of necessary if it is implemented in itself. And at the same time, it's pretty performance. So, any question?
Oh, yeah.
So I wanted to go through a quick 101 of the language. So you can see some differences from others. There are 1 or 2 particular, like, novel. First, we can start with the Datatypes description. As being an object-oriented programming language, everything is an object. And we gather two main groups, value types and reference types. That's similar as in .NET, for example. Value types are stored in the stack. So they are passed by value when you are using arguments and functions. Basic, bool, nil, and char. Different kind of numbers of different precisions, similar as in C. And there are other value types, which are structs, tuples, and pointers. Tuples are like fixed length arrays that the compiler can check the length, so you have like some safety when accessing the indexes there. And you can define your own structs as in C. And then you have the reference types, which are allocated in the heap and are managed by the garbage collector. Currently, we use BOEM, but that might change in the future. We just need a garbage collector. And it's doing the work well enough. Most of the types will be reference type for sure. When you code your own classes, there will be references, but you can shift to struct in order for performance reasons. For example, if you are coding a color or a point class, you might have a point struct instead of a class, because that will it will stress less the garbage collector. But then one of the types that is not seen enough in a lot of languages are union types. Union types are one of the cornerstones cornerstones of the language because it allows the feeling of a dynamic language without being a dynamic. For example, we can have an array of a mixed type, or actually of a single type, a union. So there's a kind of tricky word there. So we can have an array with integers or strings. And when you access when you difference one of the indexes there, you will get an integer or a string. You don't know which one at compile time. So you will need to handle both cases from there. For example, another example is when you want to find the character in a string, the result might be an integer or a nil if the character is not present. So yeah, that pipe means the union type. Yeah. If we go to the memory representation of unions, usually when you need to packet for example, if it's a union between bool and integer, you will need to store the value and a type discriminator to know which kind of value is present on that variable. But sometimes we can do better, like for example, if it is a reference type and the value is represented by a pointer to the memory, you can use the null pointer to represent nil. So here in memory, there is no difference between C, for example, or between other mainstream languages. But the thing is that nil is not a string or in the type system.
So you can have a nil string.
You can't have a nil string.
Can't have a nil string. Okay.
No, you can call without null pointer exceptions,
right.
Because nils it's not a valid value of every single type. That implies some decisions in the standard library and how to handle those nils, because sometimes you might have a nil and you don't want a nil, so you need to overcome that thing. But essentially, the compiler will trace all those possible nil values explicitly and will force you to catch them, avoiding nil exceptions if you code with those safety nets and if you use them. But in memory representation, sometimes there is no penalty at all. It's all handled in compile time, and so if the compile succeeds, it will run without the difference in runtime as in C, for example. What else?
While you're on types, have you written down the type inference algorithm?
The type inference?
Yeah.
Yeah.
Is it something that you can hold in your head?
Not entirely, but we will see some examples of that. But it's all written in Crystal, so.
Right, but it seems like you have this union types, and you've got a type inference.
Yes.
And this is a hard thing to do in a language with that principal typing.
Yes, there is no global type inference. Actually, there are some. So it's intermediate between global and local. Let me go through some, but then we can later go on into the details and try to see that. I was involved in designing the algorithm. One of the main author of Crystal is Ari. He codes really fast, like crazily fast. So it's hard to follow his code sometimes in the time of his producing. But the meeting of designing how the algorithm works, they were done in the team. So yeah, you can hold a big picture there.
If you have string or nil like this,
yes,
can you still call methods or access fields without like explicitly testing for nil?
Mm-hmm.
So that'll just happen automatically.
As long as nil responds to that. So nil is just one more value. That is like a singleton value of the nil class. If you call a method over a union, as long as all the possible members of the union responds to that method, everything will work fine. If not, the compiler will tell, well, you're like not handling this case. So you will need to explicitly make a decision how to handle that. You can make like a like if nil, don't do nothing, and if it is a string, do this, and that will end up with a nil if the original value was a nil, like maybe monad in Haskell. Just you will end up propagating the nil values, and if it was a string, you will apply the operation. So you will end up with a result of the operation or a nil if the source was a nil. There are some idioms on that, but it's not hooked in the compiler, but on the standard library. So it's more a design decision of the standard library how to handle that.
Do you have a kind of type case statement in the language?
Case types.
So you can say if string, then this, otherwise it will do this.
Yes. Yeah, if you need to explicitly do that, you can. But if the idea is like, if on runtime it will end up working because all the cases of the union are handled, just do the work. Like the idea is that the compiler should be like an assistant for the programmer and will do a lot of work. So that's why the compiler is kind of big, because it will do all the maths to, okay, yeah, this can work, or no, I don't know if it is work, and that leads to a compiler error. Ruby has some nice features for making DSLs. Those are based on blocks sometimes, so you can write a method that will yield some execution of a code that will be given by a block. So this example is something that will run 10 times. Depending on the implementation, allowing to pass blocks to a method might incur a performance penalty. But in Crystal, we don't want this, so we basically do some inlining when blocks are involved. So you can have a great expressiveness and good support of DSLs, and at the same time, don't compromise the performance. So yeah, this is being in line. And for usually when you start like doing more advanced things with the language, you start needing a way to have anonymous functions or pointer to functions or some sort of callbacks to be stored. Basically, Crystal it's big enough already. It has proc support. So you have anonymous function. You will say what is the argument. You don't need to say what's the result type because it will be inferred. You can call it. And procs can even move to closures. That means that it will have state between the lexical scope of the code. So you can have a function changing that reads or writes the state where it was defined. There are some constraints, but usually when you start seeing closures, you start figuring some of the corner cases of procs versus closures. Nothing too important as a cornerstone of the language. It's just that we have support for that. And being since we have types at compile time, we can do method overloading during compile time. So we can define overloads, and those overloads can be picked based on the types of the arguments, on the numbers of the arguments, or even the name of the argument, because we have a named keyword for some methods. So we can code on the left something in Crystal, some basic operation with overloading, and it will work, and the compiler will choose at compile time only once which is the appropriate overload to be run. But for example, in Ruby, or usually the same is happening in JavaScript. If you want to have some sort of overload, you need to handle that on runtime on every single call. So you are compromising the performance there because you are not able to say, okay, yes, this call is for this overload, this call is for this other overload. Besides that, the method looks weird. You are mixing the overload and the semantic of the method if you do that. So you have overloads like in C. You can define many methods and base it on the number of arguments. Or C++, you can do that. The type inference. So that was like basic structure of the language, how the pieces of the grammar mix together. And in order to to be able to code this in a fun way or in a joy, assuming that programming is joyful for programmers. Like in Ruby, you're able to don't annotate any variable at all because it's totally dynamic, and you just need to create when you instantiate a new instance of a class. Well, you need to mention the class there, or if not, sometimes not even there. You can pass the class as a variable. It's really dynamic. But since we don't want to do a lot of type annotation, explicitly mentioning types, we need some sort of inference for the compiler to start writing that as if we would have been doing it. So for describing a type inference, the basic will be to describe the literals. We have literals for all those types and even regular expression also. That's easy. A literal is already a member of a type that is well known. So we have those rules in the compiler. That's pretty basic. Every time you see an expression that is a literal, you can already type it. Nothing awesome. But then, for example, for variables, for local variables of methods, each time you have an assignment, if you read that code, you expect that variable is able to store the value represented by the right-hand side. So you try to type the expression on the right-hand side, and you bind, you make an expectation with a sort of binding. You bind the variable A to the type of expression of the literal one. So that's like it's an expectation. That is propagated across all the statements of the program. So now if we assign the variable A to B, we are expecting that the B will hold the type of the expression of the variable A. So we are start like making bindings between expressions, between the nodes of the abstract syntax tree of the language, and those binding will result on the judgment of which is the type that each variable should hold. If there are multiple execution paths of the code, we might lead to different expectations. For example, on one side, we might have that a variable is an integer, and in another side, it could be a string. So at the end of in the midpoint of the program, we just say that, well, it might be it will be a union because it's either an integer or a string, nothing else, but it will be one of those. So unions here are part of core because this allows you to don't care about if it is the same type in both branches. It would probably be if you are programming in a clean way. Usually the variable is used for only one thing, but sometimes variables change across the time. So it's pretty handy to have this in an automated way. You don't need to explicitly say I want A to be a union between. No, it will be a union. So in this example means that since A is a union, when assigning an integer, it will do that packing for that A. It will say, okay, it's the integer and the value, or it is a string and the value of the string.
Does this work for like all assignments of A? Like if you had the first assignment of A that dominated this, that was int, the assignment to string would still update. Okay. Yeah. There
are some analysis. There is something called a single static assignment. Mm-hmm. Basically, it handles some sort of order of the assignment, so you can forget what you said before. You have a new information there. But yeah, there is no constraint about which assignment. With loops, you have some special cases, but it's basically it will work as you expect. The idea is that the compiler do the math, like just get me there.
So wait, if you had A equals 42 and then like not an if statement or anything immediately after that, A equals hello.
Yeah.
The type of A would still be int 32 or string? Or would
no, it will be string.
Okay, good.
At the very end, it will be string. So there will be different A's actually for the compiler. because it will.
Right. So okay, that makes sense.
Yeah. So
as you said, the literals determine the type. So if you have a variable type float 32 and you say x plus equals 1, does that work, or do you have to explicitly turn 1 into a float?
It will be the plus between floats and integer. So
it's an overloaded plus operation.
Yeah.
Okay.
You said plus.
Yeah. X equals x plus 1. Let's say. Yeah.
Yeah.
Okay.
It will be that overload, and how that is handled now. It's probably do the conversion and then apply the operation.
Right.
So, but that might change if from the standard library.
I have this sense that programmers must spend a lot of time accidentally creating union types when they just made some minor typo, and that the compiler says you've got int plus a string plus an int 16 plus a nil, and it's just because they made some little mistake they then have to fix.
That might happen depending on the sort of programs. Something like that might happen. Unions doesn't occur that much, or it's not more than 1 or 2. And sometimes if you add some, for example, you are coding a lot, but you know that the result needs to be a float. You might do the annotation of, I expect that to be a float, and the compiler will highlight, well, in this path it's not a float. So you are able to have some sort of discussion with the compiler. If you don't express anything, the compiler will do as much as it can to make it work, even it's creating a lot of unions. But usually that's not a lot of the cases. Like, we envision something that works for the 95% of the cases, although you can build some weird cases. That's not what happened. And we had come back and forth on some ideas on how type inference should work. I can tell you the history a little bit later. But yeah, so you have this type inference. And for method calls, what it happens is that first you type the arguments, and then you search for all the overloads available for that method names and that arguments. And when you find one, you basically do an instantiation of that method for that particular argument combination, and you do the process using the context of the types of the arguments. So in this case, you will know that x should be an integer because the return type is integer. And if you call with another overload, you will have again another instantiation. And since strings can be added, that's end up in a string. So this is kind of C templates, if you would like to see it like that. It's like every method is like a template, and it will be instantiated when it's being called.
And let's say this add method function had plus double quotes in it. Yeah, and the first overload would not be a valid one because
it will not compile.
Right, but it would just not find that overload, but it wouldn't be an error. Is that?
As it is, if I add a plus double quote at the end of A plus B plus double quote, the first one, it won't compile because the overload is that one.
Right.
But the body doesn't compile because it will be trying to add an integer and a string, and it will fail there.
Okay.
Not in the method itself. And the second, it will run.
But you could have another overload for add that was a valid.
Yeah.
Okay, right.
Yeah.
So if I have two variables, A and B, and they're both of type int or string,
Yes.
and I call x equals add
Mm-hmm.
A comma B, what happens? I should get a compiler error. I
Yeah,
guess.
you will. Because in your head, they might be correlated because it's either both are strings or both are ints, but the compiler doesn't know that correlation.
And if I have something where it's just, foo, and it takes one parameter, and I have two implementations, one string and one's int, and I have an int or string, it figures out which one to call it at runtime.
Yes. In compile time, it will gather, it will check if there are enough method overloads for all the
You
definitions.
just put a case,
And it will
generate
do
a case
this, yeah.
statement at runtime?
Yeah.
For runtime?
That's basically called multi-dispatch. So it's available on other languages, not in mainstreams, I think, but it's called multi-dispatch. So the ugly code in Ruby, it's generated by Crystal, but in those cases.
So it generates a case statement, basically.
Yes, if you have unions, yes, or at least right now, that's how it's working. Again, if for a performance reason, we think that it's better to expand it differently, that could change. But for now, that is how it's been working good as far. Complicated example. Here we have a factorial function. We are calling it, and we want to type it. So the first step is instantiating that over an integer. And since we want to know the return type of that method, the only statement is the conditional. So the return type of the function is the return type of the conditional, and that's a union between the two branches of the. On one side we have the asterisk, and on the other side we have the literal, but we won't see that for the moment. If we go on the left-hand side, we have another call. Actually, we have a call, and we need to resolve the argument. Let's transmit that an integer minus an integer leads to an integer. So that leads to a call of a factorial with an integer, and the other argument is the n. It's another integer. And if we want to try to type that recursive call, we could end up in this same process, because we don't know exactly the type of the factorial. But what we do is to bind the result of this recursive invocation to the thing that we are trying to resolve this. So there is this kind of graph being done by the compiler. So actually, when we created this graph initially, the return type of factorial was unknown. So now we have unknowns in the left-hand side of the graphs going around. But we have so we didn't get any new information from the left. But from the right, since we have the literal one, that's get injected in the union. So it's a union between something that is unknown and an integer. So that will be at least an integer. So we said, okay, the union is an integer for now. So the top factorial it's supposed to be an integer for now, and that's go plug it in to the bottom part. So now we can resolve that is that the multiplication between an integer and an integer, that's leads an integer. So now we have the union between two integers and leads to another integer. And that's finally leads to a fixed point on this algorithm. It could happen that it will get another type of the union, so the union will be updated upwards between an integer and something else. And that process will continue running until you have a fixed point.
It always terminates. It always terminates.
Yes, at least. No, it terminates because there are some bounds in the type system, so you can't have infinite types.
Okay.
That's how because it's like it's only going up the unions, and you have a finite amount of types, so it will end eventually. Right. And unless you allow infinite types for the same source of code, or at least it ends in the cases you need to handle. In the normal cases, it ends. You can code a weird case probably in the near future that won't terminate, but that's probably not a problem you're interested in coding. So yeah, that ends. And another example, for example, this case when we index a variable and we have an nil or int, if we try to access the character at that index, this leads to a compiler error because there is no overload for nil, because it could be a null pointer exception in most of the other programs. So what you need to do, for example, is, okay, if I have an integer or anything that is not nil, it will be scoped in the scope of the conditional, the variable idx, it will be assumed to be an integer. So you have like some kind of refinements of which is the type of that variable because of the checks. You can even do some checks explicitly by type or by case, and you can do Boolean operator there, and the compiler handles that. So you can have A and B are integers and both will be integers, and that works. And for classes, for example, you need to be able to determine the type of the instance variables by the class code. That means, for example, from this method, you can think.
Can I quick question about the previous slide?
Yes, sorry.
Sorry. So actually one before, you said if index. So that means in this block, which is dominated by a non-nil condition.
Yes.
You know that index has only type int32. If you were to assign to index within that block, what would that work?
Inside the conditional?
Yeah.
It will be another variable after you mention that. So
so you can't say if index equals nil and then assign to index inside that block, make it non-nil.
If
sorry.
No, it's okay. But
so no, it's a new variable inside the block.
Yeah, it will be a
type, and I'm wondering. So it's a common pattern in C-like programming languages to say if x is nil, then give x some value. And it seems here you're assigning to a variable that has only one type, which is nil. And
yeah, but
it would rebind it.
It will rewind. It will be like a new variable.
But then outside the if block, the effect of the assignment.
It will create a union.
Because
it's inside the if. What happens if the condition doesn't match?
Okay. All right. So it's not a new variable. It's just a restriction of the type of.
Yeah. This is if you know you are checking that it's not nil, so you are able to call some overloads without caring about the previous case. We have an integer or a nil, but we only have accessing characters by index.
Okay. So it's the same variable, but it knows more information about its type at that point. Okay, got it. Thank you.
And regarding classes, for example, here, instead of, you don't need to declare explicitly all the instance variables, but in this example, from the argument name that is restricted to be applied for strings, it knows that the instance variable name should be a string also as well. So this works by the type inference on the classes. And another alternative will be to explicitly code the instance variable. That sort of works for documentation purposes also. Sometimes you want to, when you are designing, you want to explicitly type the instance variables, but it's not always necessary. So we see that we have an instance variable from the argument or explicit typing, or you can even have like assignments from literals, or in this example, this is a generic class. You can create a new, and the compiler know that at values should be an array of t. And that works. Like, it's a convention that if you apply new to a class, it should return something of that type. If not, you are probably screwed. So these examples work, and this is, for example, a generic class. So we have generic classes as well with type parameters. It's what you could expect. Ruby, you don't need type generic classes because it's dynamic, so you don't care about that. But in Crystal, since it's statically typed, you need this. Okay, so we have a nice syntax. We have a great compiler with a lot of type inference that allow us to not care about some bureaucracy of types. But in order to be able to perform good, we need a good support of concurrency. And in this, we base our work on Erlang and in Go. So we basically have this same sort of mechanism. We have some lightweight process that abstract the threads of the operating systems, and you can work without using mutex or other async mechanism, because you have like these fibers or routines that when you started, the main program is still executing until it performs an slow I/O or a blocking operation, like a web request or something. And when that happens, you will be scheduled until that slow operation ends, and the scheduler will pick up the next available fiber to execute. Between that and the communication mechanism that is channels, again, similar as in Go as and Erlang. The main thing is that you can code things linearly without callback hell. As in, like when you end up an operation, you need to have a callback for success or failure. You can call linearly. You make a request and you have the variable that will end having the result of that request, even if it does end up doing sending you to the idle pool of fevers until that is completed. So spawn is a keyword here that start this process. And
you have select.
What?
You have select.
We have select, yeah. We have select, and there was added some timeout also support, so you can call that without having timeout thing. I think that's already reached master, but although it was in a branch somewhere in the language. So yes, you have those mechanisms. Currently, Crystal is single thread. We don't have parallelism yet. That's one of the goals for the upcoming months. So all the benchmarks before was on single threads, and there are a lot of benchmarks going around on blog posts, and it's single thread.
So you can do I/O in parallel, or not even I/O operations.
No, you can do I/O operations, but it's handled concurrently. You schedule the read, and when the read ends, it will be available for picking up the result.
So it's like Python in that you can have multiple I/O operations in parallel, but only one actual thread doing computation. So
yes, so it's only one thread. Yeah. For now.
For now,
the idea is to reach parallelism.
There's several processes in there, right?
Yeah. No, you can fork it and make another communication mechanism right now, but it's like doing that work manually. The idea is to have a parallelism built in the language. It will probably be more similar as in Go than, for example, than in Rust, because I don't know, we feel more about going on that direction. At least for now, we are still researching and learning from other languages. And another aspect that Crystal handles, I think this is it's almost the last of the 101 of the Crystal, is metaprogramming. Ruby has a great support for metaprogramming. Sometimes it's used to avoid boilerplate, things that we hate to do it once and again. So for example, if we have this code that defines the same methods, some method accessors, we can use macros, which is like a subset of the language. It's like a new method, that the result of that method is code that will be like inlined in the definition. So the person can be coded as calling the macro getter with the address and the age. So that will expand to the valid code, and you can do a lot of things with macros. It has that curly braces syntax that all templates do now. The thing that is a little bit different from C macros, for example, because there are not C macros, they're nicer. Actually, the macros receives a representation of the expression as AST, as syntax tree. So, and you can access that information. So you can receive a block and get the expression of that blocks, and I don't know, shuffle around the instructions. Not recommended, or you can surround that with other things, or inspect or change that code. The code that is output by the macro is the one that is analyzed. The previous code doesn't need to compile. So actually,
it's Lisp macros without Lisp syntax.
More or less,
okay.
Less powerful for sure. Or you can receive a symbol and convert it to an identifier or to a string, and so you can define methods or do something very random. Actually, in the previous example, address and age are parsed as method calls or variables, but then are not used as methods.
So you have to know the internals of the AST to make use of macros.
If you want to do advanced, yes. If you want just to interpolate things that you're receiving, you don't need to care about. But there are some limitations about what a macro can receive as an argument, because it needs to be valid Crystal syntax.
And can you evaluate expressions of Crystal in this language?
There is a subset of Crystal that is interpreted during macros. Yeah.
Can you require specific types for the macro arguments?
Yes. And you can even have a support for type introspection during compile time. So, for example, all the structs are, when you call a new struct, you will have a new equality operator based on all the members, on all the fields. And that is not in the compiler, but on the standard library with all the macro mechanism. So that's code in the standard library. So it's pretty neat. So I like that. I have a struct and I already have a lot of operations. And you can go even crazy and run external process to generate code somehow. There is a module called ECR that is like embedded Crystal. Similar, it's a template that it will allow you to generate a to-string representation, for example, for HTML views or whatever. It's pretty neat and it's compiled. So you have a compile time check of the views as you used to have in C# and ASP.NET, but in Crystal. Then the standard library is pretty big. There is support of a lot of things that you want to do for either command line tools, servers, HTTP clients. We have an HTTP server. There is an HTTP2 server made for someone else as a separate shard, like a package that you can consume. And there are database driver that writes directly on socket, pretty optimized. So without actually native dependency, you just implement the protocol, the MySQL or Postgres protocol over the socket. And the design of the I/O is stream-oriented, as you can see. So you can read and write as in streams. So and to decrease, there is a lot of focus on decreasing the memory consumption. So when parsing or generating JSON, the API is aimed for that, for streaming all the results all along. We have support for interacting with C. You declare bindings to C in Crystal itself, and you are able to call that those functions or even declare structs without leaving the language. And LLVM will Crystal through LLVM will handle all the going back and forth, and you have support for callbacks. For example, in C, you can translate to Crystal and receive and binds to UI libraries if you want. There are some already going there. So basically, nice syntax inspired for Ruby, LLVM, a great thing to build compiler. We're inspired on a lot of languages. We hope to inspire other ones for sure. The motivation is the compiler to do as much work as possible. Currently, the community is pretty good. You can join the mailing list, and there are meetups. There's a great support. Not always is the people in Manas that respond to that. There are already great contributors. We have external contributors that are not members of Manas, that are committers in Crystal already. We focus on having nice documentation, so we care about that. There are already like 1,500 packages already. We are sponsored by whoever wants to give us money, even if it's $1 per month. We have 80 sponsors, from $1 to hundreds of dollars, but that's it. On the next months or during 2017, our goals are to have multi-threaded concurrency, Windows support, and polishing the language features to reach 1.0. So we don't want to have breaking changes, but so those are the main goals. Although there will be developed in other areas for sure. Yeah. So that is the future, the near future of Crystal. There are great tools, there are great things being done, and as soon as we get more feedback, there are more chances to change things. When we reach 1.0, we want to be able to not break things backwards.
Question for you.
Yeah, sure.
What programs do you want to write in this language? what kind of, every language has a
Yeah.
niche, and often it's not the one you set out for, but it usually is an intentional goal is to fill some kind of niche. Which niche are you trying to fill?
We like, it's a general programming languages. So it's not that we aim for something really specific. It's in the current state, it's really good for writing command line tools, for example, or handling short requests for processing, like background processing. It's really great for that. As there is no big framework of like Rails that you can come in and say, yeah, let's go and crystal this web application, because there is a lot of the ecosystem that still needs to evolve. But since there's similarity with Ruby, there are many people that want to push it that way, because it's a community that is suffering from performance, and shifting to this new language shouldn't be that hard because of the similarity of the syntax. Although it's a new language, there's no guarantee. We don't aim to be a subset of Crystal, of Ruby, or we don't aim to compile Ruby at all. It's just inspiring syntax. So there will probably be a good support for web. Currently, I would say that for background processing, it will be great, or handling APIs. Like if you want to handle a lot of requests with a lot of performance, that's good. Doing a whole web app with UI, maybe it's not the best thing to do right now, because you don't have a lot of the tool chains available. You can do it because it's just a process. You build the executable. You just ship the binary to the server. You might even embed the assets in the binary, and it's just an executable that will listen to the port of the web app. And command line tools are pretty good because, for example, you don't need to load all the package and parse the files. It's already compiled, the tool, and it will run really fast. So I think that's the current story. We use it nowadays for some bots, like Slack bots, or for running some small web applications. And there are some projects already in production by some people, and in the game industry, or in the attending like web requests, or attending in background. And for example, Mike Perham, the author of Scikit, which is a package for background processing in Ruby, it made support already of Crystal, and it was like awesome experience for him. Like in 3 days, he migrated the code, and it was like great performance. So that, I think, if you have like your favorite C library that you haven't used it in years because you don't want to code in C, you can have a fresh air in Crystal and bind it and do it. And yeah, there are even tools that will code all that bindings to C automatically, parsing the C header files.
Do you have any tools to help people migrate from Ruby?
No, we have a wiki of the differences between the two languages, but we don't aim to migrate the code.
Thank you so much.
Sorry, thanks.
Have you ever looked at Julia?
Check stickers, or you can take one of each if you want.
Thank you.
Sorry, come again?
Have you ever looked at Julia?
Not personally, but Ari and Juan, which are the other two main authors of Crystal, they like it. There are some similar.
Yeah,
similar
I mean, yeah, I'm not an expert in either one, but it seems like there's a lot of similarity.
Yes, everybody's trying to reach the new mainstream language. I think there are a lot of similarities. They're shifting back to static type languages. We want that security again. You have stickers, and you can make the crystals here if you cut it. And thank you very much. However, you can join the main list, the webpage, send emails.
Great, thank you.
Thanks.
Thank you.